Hello everyone, welcome to High Performance Computing Advanced Scientific Computing course. This is lecture 15, Green Energy and HPC Applications. So as we're following the outline of the course, and this year was CFD Special, currently we are continuing on the lecture 15, and we will discuss the relevance between the green energy and HPC, which is somehow the demand of the energy is related to HPC, and also how the HPC helping to conduct the research and develop the green energy. As usual, let's have a review on lecture 14, which was hyperparameter optimization and AutoML. There was a presentation about the importance of the hyperparameter, why hyperparameter is important, and how it's mm, improving the performance of the machine learning of deep learning model in connection to the HPC. And some term of the hyperparameter it's defined. What are the hyperparameter? For example, when we are working with machine learning model, what parameter are in these categories, and need to find them. Usually, traditionally, for example, in the most of the physical application, when we are using the machine learning deep learning, selecting of this hyperparameter, it's using the traditional approach. We can say with trial and error to find the best value for the hyperparameter. But in this day, with development of some software, these ability developed much better, and we can find the hyperparameter with automatic system. However, using this software also sometimes has a demand of the HPC to find the hyperparameter values. And there was a good example in this lecture, the importance of the hyperparameter. You saw some examples of how it's important and helping to uh, improve the model in terms of the performance and also in terms of the speed up. Additionally, regarding the GPU allocation, also in the hyperparameter, there was discussion and provided a perspective that how you can use the hyperparameter tuning in your application. Now let's move on to our lecture. So in this lecture, we will have an introduction regarding the sustainable energy resources, which is mostly well known at this time, and all of us will know the importance of the energy and what is relevant to climate change and global warming. And there are a lot of effort to uh, develop the application of the sustainable energy in our daily life. So we will discuss how the HPC helping us to approach this goal, and also HPC with the computing is required energy resources, power resources. So when we are working with a large number of large size of the problem, of course we have high demand of the energy. So we will have some example, and we will see how the energy demand in the HPC also is important. Let's start with the green energy and what's its definition, and why we are using the HPC to solve or simulate some aspect of the green energy or renewable energy problems. Regarding the renewable energy resources, we have the solar power, wind power, geothermal, hydropower, ocean energy, and bioenergy. This is most portion of the sustainable energy. In some kind, there are some other application like currently the hydrogen energy. It's the another resources it's developing, and there are new application of it. Let's focus on these most applied resources and see some example, which is relevant to computing and HPC resources, and additionally why it's demanding also the HPC system. The solar, as we know, it's based off the irradiation that it gets from the solar system via the flat surfaces. It's called photovoltaic panels, and it's converting in space of the processing of the energy could be converted to the electricity. The winds working based off the equipment, we call them uh, wind turbine. There are different type and category of these wind turbine, small scale, large scale, and regarding their structure also, there is a horizontal wind turbine, axial axis wind turbine, and they are working based off the flow speed. There are different design of the height for the wind turbine, and also regarding the shape of the profile on the blade for each turbine, and it's leading to different performance. Regarding the geothermal, also is based off the uh, high pressure and high temperature water comes up from the wells in the earth, and with this high energy water, it's fed to uh, turbine and turning the generator and increasing the power for us. The ocean energy also, there are different method to use this ocean with the wave of the ocean, and how with different level of the water we can turning such a turbine and creating energy. Also, there are other approach in the development. The bioenergy, of course, using different sources on the earth to convert them to the energy, which is also has a different method and different resources in this area. Uh, in one aspect, these resources can feeding and supplying the required energy on the HPC also, rather than other application in the industry, on the uh, cities and development of the smart cities also. However, to developing these energy design, as we said, each one working with a specific equipment. For example, the wind turbine, we have it to energy. The photovoltaic panel, we have it in the solar energy. As much as possible, when we improving the design and making the optional design for them, we can have a high performance, high efficiency of the energy production. So that's why it's important to be able use the HPC in the design of these energy resources application. Let's have a short review on the importance of the climate change and global warming and why it's relevant to green energy application. In fact, regarding the climate, we have term of the weather and climate. Weather, in fact, the change of the pattern which happening in the short term and locally. For example, about the rain pattern, we can see in the short term it could be changed in the local area. But the climate change, it's about the changing of the climate, in fact, changing of the pattern for the long period, like during the 30 years. So this is the different term between the climate and the weather, which is very important. So when we are looking for the global warming and the climate change also, global warming, it's relevant to global temperature change after the industrial revolution, which increased the temperature because of the using of some mm, fossil fuel and coal and such of these energy resources. But the climate change is regarding the change of the global pattern of the weather in the long period globally. So this is the difference between the what is the global warming and what is the climate change. So we are assuming when we are studying these different phenomena because of the size of the problem and because of the term of the change, using method like CFD, what we talked in this lecture, required large computing. So we need the HPC resources to deal with such problems. And in fact, in this area, usually we are dealing with many parameters. For example, here we can see uh, what parameter impacting the temperature of the area near to a lake, or when we have many different parameter around the area, and what how we can find the correlation between them, and how it's taking a calculation for such simulation or model. So it's very important to be able use the capability of the HPC in this area, which is so helpful. And in this day, we can see many research ongoing using the CFD, for example, making a simulation, and also from the other application from machine learning, for example, using data from remote sensing to monitoring some changes like the glacier melting or a level of the lake or the ocean maybe or the sea near to some cities, which is used with the large and extensive data processing with the remote sensing. So studying and monitoring the global warming or climate change with the HPC, of course, it's important, and it's indicate how much a species can help us to monitor and know about these changes. From other view, looking at these two terms of the global warming and climate change, it's also emphasizes that we need to use the green energy and sustainable energy resources in our application of the HPC to reduce the effect of the uh, effect and impact of the environment by these systems. Shortly, let's look at some example of these energy resources. For example, the wind energy, as we know, we have the wind turbine, which flow over these turbine, leading to generating the electricity. Also, there are some important aspects need to be understood for the wind turbine. For example, when placing a number of the wind turbines in a farm, there is a event. It's called wake loose effect, which each turbine impacting the downstream installed turbine with the change of the flow, which is from the fluid dynamic area, and could be impact and reduce the efficiency of the turbine. So it's necessary to use the capability of the CFD to make a simulation of this wind turbine and study the effect and reduce it. Also, for example, recently some research presenting installing the wind turbine, offshore wind turbine near to the city, can to lead long-term pattern change of the weather to the city that's located downstream to that offshore wind farm. All of these need to have a much more simulation and study with the CFD, of course, with large computing to understand what's happening. And also about the wind energy, there is another wind turbine. It's called vertical axis wind turbine, which gets a lot of interest these days because it's working much more flexibility, uh, and there is no known wake loose effect from this wind turbine. And because of the importance of the effect of this phenomena, uh, currently using the HPC to simulate these wind turbines are important to understand the impact of the wake loose effect of the performance of these turbines. Well, regarding the solar energy, we can say it's one of the greatest option of the energy. In fact, based off the energy that is gained from the solar system, we can say the computing is presenting us the calculation showing us 1 hour of the solar energy can supply the energy consumption for the entire year. So that's why we can see why this area is very important. So as much as possible, we can, if we can, improve the efficiency and gaining of the energy from this system, we can have much more energy and of course green energy, which helping to supply the demand from these resources and of course reduce the impact on the global warming and climate change. Here it's the simple presentation of the uh, photovoltaic panel, how it look like and how it's processing to convert the irradiation from the solar system to the electricity. Hydrogen, it's one of the recent developed resources of the energy, which get a lot of focus and interest of this. In fact, it's one of the also clean and green energy could be used. However, regarding the hydrogen, it's the type of the energy that to produce it, we need to use the electricity to do that. Based of the, you can see an example of the electricity, how it's happening. We need to have a cathode and anode to make a production of the hydrogen from the water. However, to do that, these will be a very key and important parameter that from which energy we can produce it. For example, if we want to produce the hydrogen energy as a green and clean, and we're using the fossil fuel energy, like using electricity that produced in the power plant from the gas, so it doesn't seems it's the proper approach to produce the clean energy with using the non-green energy resources. Uh, Therefore, currently there are two important ideas that how we can use the solar energy system or the wind power energy to produce the hydrogen from the water with the electricity of the water. Uh, to do that, there is a combination power plant, which say we can have combination of the wind and solar power near to water resources to produce the hydrogen from them. Also, this led to another idea that how we can have the solar power plant and wind power plant combined together in the offshore, which making it possible, for example, at the time when there is no high resources of the wind, the solar on that area will be interchangeably when there is a solar power or where there is a wind power resources. To do that, in some cases, it's required to make a large computation if we are using the CFD and simulation to study these energy production. Developing the green energy application is very important. As you can see, based off these United Nations solution in this report, that there are 6 sectors of the solution to the climate crisis, which we can cut 12.5 gigatons of the greenhouse emission annually. And we have the necessary technology for it. And just we need to conduct uh, these technology and how we can make much more efficiency on these such resources like wind energy or solar or hydrogen, and mm, reaching this cutting of the greenhouse emission. Here I'm presenting these figure with how the power grid is distributing the energy between different applications. Of course, it's first of all the power grid will transfer the energy for the power user in the cities and inhabitants, and then we have some facility in the city like train or tramway, and also with the electric car currently, it will supporting the required power for them. Additionally, with the new term of the harvesting the hydrogen energy from the water, we can use this power to make that. Additionally, with the development of the research, the computation, the CFD simulation, and all of the other computation that is available, of course, in the science and in the industry, using the HPC, it's necessary at this time. Then we have the other parameter added to the power user as a HPC system. And since we are reaching the necessary of the computing like exascale, and of course it will be development of the future years, this demand needs the proper supply to use from the green energy and sustainable energy. That's why in this example you can see how the wind energy is important and can make all the supply from the green resources. Furthermore, how we find the connection between the HPC here and wind energy, for example, in the wind energy there is a issue and obstacle about the wind prediction because when the wind producer, or we can say the wind farm, need to respond to the demand available from the user, they need to have a short or long term of the prediction of the power production, which is exactly relevant to the wind speed. The wind speed basically relevant to weather prediction, and also in recent years there are some applications of from the machine learning and deep learning working with data from the recorded or measured data for the wind speed to make a prediction for the wind speed. Then when we have a prediction from the wind speed with this model, we can feed the system in the wind power or wind farm, and they can have a prediction of the production in next period, which could be long term or short term. Regarding the short term and long term in the literature, there are different definitions. For example, regarding the short term, it's from a few hours to 1 day, and for the long term, it's from 2 3 days to 10 days. There are different results from these application. However, this is emphasized on the application of the HPC because when we want to use the prediction model of the deep learning with extensive data, for example, measurement of the wind speed for 10 years, it will be extensive computing, and we need to have access to the HPC resources. Therefore, here we can see there is a loop of the energy resources which the wind can supply the energy demand of the HPC system, and from other view, the HPC helping to improve the efficiency of the wind power production with these prediction models. This is an example of the how the green energy can have a cycle between the production and also improving the performance. Some other term regarding the HPC system, usually the supercomputer, since they are physical equipment and working in some equipment with some heating, it's getting some heating. So we need to control the heating with the cooling system on the HPC. Usually, especially when we have high demand of the computing on this system, this increasing the temperature and heat on this system and need to be controlled. So the cooling resources also for this system is important. There are different system that making the cooling on this system, and Therefore, here also it's presenting the HPC from other aspects with the temperature also uh, have some effect of the environment or the climate uh, can control with the cooling system. Here you can see presentation of the sustainable energy for the HPC and how the energy management strategy for the HPC cluster could be had in different manner. You can see the CPU usage and also the power on the left hand side, and you can see with different uh, control theory and policy how it's behaved differently and which one reducing the mm, power usage much more than other. Uh, with these, we can understand that HPC from different aspects, from the uh, demand of the energy and also from the heating which happening with the demand of the computing of this system has a different effect of the climate change. So it's from this view, additionally to the HPC helping us to developing the efficiency and performance of this system. Also, it need to we have a control on its effect to make it much more uh, environment friendly, and we can say climate friendly to reduce its impact. Following up our example about the HPC energy demand, here we can see when we have different energy resources from the wind, from the solar, and also from the fossil fuel energy or coal, maybe how it's working. For example, from the computation for the petascale era, how we are getting to the exascale currently, the consumption for the power for a single machine it's around 25 megawatt. With increasing of the size, of course, this demand is getting higher. Additionally, uh, development is getting us to have much more high computing. So there is a design and location for the new system, which is important where we place them because it's relevant to the power distribution network capacity and the arrangement to respond to this demand. Which all of these parameter it shows the importance of firstly that how we can harvest and use the green energy resources, and from other view how we can make a loop between the HPC system to helping us improving the green energy, and how uh, also increasing the HPC system will lead to some impact of the environment and also for the energy demand. Regarding the power distribution for the HP system, also there are some element and criteria need to be pay attention. For example, it should be a secure transmission system because when the HP system is working, and of course on the demand, assuming you are running a very big problem and it will taking maybe couple of hours or maybe days, if there is no secure distribution system and shutdown is happening, all the previous computation maybe will be lost, and there is again it will be net computation. So it will waste the energy. That's why for this such system it's required to have a safe and secure power system, which make to have a specific criteria and procedure for these distribution transfer for them. Furthermore, when we are talking about the cooling system, which mostly working with some power supply, it's required to keep the control on this part of the HPC to uh, provide safe procedure for the system and avoid any damage because of the heating, because of the some failure of the cooling system, which are relevant to the power supply from its resources, which could be uh, one of the green resources that we mentioned, or from the fossil energy. So here there are this key about the power distribution and how it's working, and additionally adding regular maintenance work could help us to reduce these failure and impacts of the power distribution uh, cutoff. To have example from the CFD for large scale in the green energy, here I'm presenting some example. We can see how the scale it look like, for example, the wind energy, or for the geothermal energy, for the solar collector, for the combustion engine, and the hydrogen production. So usually we are working with large scale, with a large amount of the element for computation from the CFD, which is required. As we said, we are using the CFD because of the limit of the experiment and analysis. We cannot perform the experiment for all problem. For example, here you can see example from the geothermal energy. Of course, it's we can say maybe it's impossible to make an experimental study on such phenomena. So using the CFD is required, and of course having access to HPC system to deal with that problem, to understand the problem, and then use this information to design the facility and the equipment and harvest the energy from these resources is important. Here is another example for the CFD application for the cooling system of the HPC. As we mentioned, it's very important uh, because of the cost of the HPC system, and also about the demand of the computation of this system, which is uh, done by the user, and it's very important. Uh, there are different uh, currently system used for the cooling. For example, the air cooling. There is a direct air cooling, and there is open water cooling system to improve the design and to understand how this different setup is working to help it to cooling this system and avoiding the damage or failure of the system. CFD helping to see how this system making cooling and controlling the temperature of the system. With this size of the computation also, it's required to have the HPC. Uh, the benefit of the HPC also in its side to control the cooling system for it. So to wrap up the HPC and green energy importance, from one side we said uh, for simulation and studying of the energy resources and their equipment and improving the efficiency of the green energy resources using the HPC, it's required in terms, for example, in the CFD simulation or other studies or other computation. For example, it's using the chemical interaction also. It's happening, for example, in the hydrogen, or maybe in the uh, reaction of the combustion in the engine, which using the CFD simulation or heat exchange simulation. So all of these simulation and study and development or engineering design require the HPC system to do that. From other side, the HPC requires the power supply to response its demand in the computation, and it's very important to have a stable and secure energy transition to keep it stable and respond to this demand. Furthermore, there is a heating because of the demand of the computation on the HPC system, which need to be controlled with the cooling system, which cooling system also is relevant to the power supply and the most efficient cooling system, which is depend to the HPC design. It need to be selected and modified and optimized. Then there is a loop or cycle of this term of the HPC CFD or other computation, and the energy supply to keep all of these working properly with the required computation and the required energy supply. Of course, with increasing of the demand of the HPC, if we want to stay of the using the fossil fuel energy, the impact of this energy will transfer to the climate change and global warming. Since we are looking to reduce this impact, of course, using the green energy to supply this system will effectively reduce the impact and uh, the side effect of it. In the term of the perspective of the energy demand of the HPC, as we know, this area is developing fast, and currently we are entering the exascale era. So in the future, also we will increase on this power of the computation. Therefore, it's important to have the proper energy resources for it to respond its demand. Also, there are some metric. It's helping to uh, have a electrical solution for the electrical distribution network design, which here we point to the connected power, which is a parameter indicating the maximum power consumption with the average over a period of the time. Additionally, there is a design power which defines the level of the instantaneous power for which the mean power supply of design, and furthermore, the contracted power is the maximum of the active instantaneous power consumed by the center under the contract with the distribution network operator. Using these three terms, there is a condition which mean this relationship between these power parameters uh, keeping the correct operation of the distribution network. So this is the example of this parametric which helping how supply the demand of the system and have a better energy supply for them. As an example, recently we had a research that how we can optimize the wind energy production, which looked connection between the HPC resources and also with the improving the wind energy production with the computation of the HPC. If you are interested, of course, its link is available in the references, and you look at this example as a use case, and you can see how it's important to find the connection between the green energy resources and HPC resources. So here we are ended with this lecture, and here is a video for the HPC for energy. And if you're interested, the link is available, and you can watch it and you see visually how this connection is available for the HPC. We will continue, and feel free to contact us for the final project. We will continue in next lecture as epilogue. Thank you and good luck.